All right, question number 5. Two particles move along the x-axis. For 0 to 8, for time particle p at time t is given by this equation, and the velocity of particle q is given by this equation. Particle q is at position x equals 5 at time t equals 0. All right. When is particle p moving to the left? Another way of asking that question, 5a. When is xp prime of t less than 0? That's the real question. So let's check it out. Well, xp prime of t is going to be equal to the derivative of this, which is going to be 1 over t squared minus 2t plus 10. And I wish it was that simple, but it's then multiplied by the derivative of the inside, 2t minus 2. All right. So we're looking for when is it less than 0. So to handle that, I think the simplest way for us to do that is, well, first I'm going to clean this up. I'm going to take the 2 out and have t minus 1 on top. And then on the bottom, I'm going to write that. So there's my derivative. So I want to find out when this is less than 0. So I'm going to look for any zeros, and I'm going to look for any undefines. So I can see that when t equals 0, when t equals 1, we have a 0 for the whole thing. So that's a start. So I know that 1 is going to be a 0, and I want to see if there are any zeros of the denominator, and I can't figure out how to factor that, so I'm just going to do the quadratic formula. So negative b plus or minus the square root of b squared minus 4 times a times c minus 40 all over 2a. 4 minus 40 is going to be a negative number, so that's going to have no solutions. So I know that this is not going to equal 0 for any real numbers. Don't believe me? Solve it out. You'll see. Or graph it and look at it, even though we're not allowed to do that on this. So that tells me the only critical number is going to be when t is equal to 1. So then I'll just check 0 and I'll check 2. So if I check 0, not f of t, xp prime of t. All right, so if I try 0 in there, I wind up getting a negative on the top and a positive on the bottom, so I get a negative out. If I try 2, I wind up getting 4 minus 4. I'm getting a positive and a positive. I wind up getting a positive. So that tells me that I was about to say that xp prime of t is going to be negative for all values less than 1, but it's not true, because I can't say negative infinity to 1, because our interval starts at 0. Remember, it says from 0 to 8. So if I look at 0 and say it goes from 0 to 1, so I can say, since the derivative is less than 0 on 0 to 1, the particle, principle, brain, particle, all right, particle is moving left. All right, so we got our first one. You can write that way, you can use interval notation. Okay. So let's look at 5b. Find all times t for which the two particles travel in the same direction. Okay. So from part A, we know that just writing that to remind myself, that's particle P. Now we got to find particle Q. So let's look. Velocity of Q is equal to t squared minus 8t plus 15. Hey, that's velocity. Remember that this is equal to the derivative of position. So this is the derivative of position of Q. So this is like, the derivative's already been taken for me. This is the derivative, and I just want to know when does this equal 0. So let's factor that. I can do t minus 3 and t minus 5. And so when t equals 3 and t equals 5, we have zeros. So if I go and make a sign chart for this one, for particle Q, I can just use the factored part here instead of having to actually plug stuff in. So let's see. If I plug in 0, I get negative, negative. That means my velocity is going to be positive. If I plug in 3, I got 0. So now we have, when we plug in 3, all right, so I got 0, I got a negative, but 0 times a negative is just 0. When I plug in 4, I got a positive and a negative. Positive times a negative is a negative. Plug in 5, positive, 0. Positive times 0 is 0. When I plug in 6, I got positive, positive, positive. So I know we're moving to the right, to the left, then to the right. So if I look at this on a number line, here's 0. The numbers, let's see, 1, 2, 3, 4, 5, 6, 7, 8. We know for P, let's see, I'm gonna put left down here, I'm gonna put right up here. So we know P is moving left from 0 to 1, and then P for the rest of it is moving to the right. And then we know that Q starts out moving to the right up until time t equals 3. So Q's moving right, then it's moving left from 3 to 5, and then it's moving right from 5 to the end. So it looks like the only times that we have overlap are between 1 and 3 and 5 and 8. So P and Q move in the same direction. From t contained on the interval, we said, wait, hold on a minute. Sorry, I was looking at the wrong thing. So 1 to 3. And 5 to 8. All right, there we go. So, oh, I called that part A. That was part B. That was our leftovers from part A, and here's part B. Okay, let's keep going. Part C. Find the acceleration of particle Q on time t equals 2. Well, acceleration is equal to v prime, so all I gotta do is take the derivative of t squared minus 8t plus 15, which is just 2t minus 8. And it just says find the acceleration when t is equal to 2. Okay, that's 2 times 2 minus 8. That's equal to 4 minus 8. That's equal to negative 4. Is the speed of particle Q increasing, decreasing, or neither at time t equals 2? Since the acceleration, or since acceleration of q at t equals 2 is negative. The velocity, the velocity is decreasing. It doesn't ask me if the velocity is decreasing, though. It asks me if the speed is decreasing. So velocity is decreasing, but we need to figure out, is the velocity currently positive or negative? So if you think about that, if your velocity is currently a positive number and it decreases, then your velocity is getting smaller and smaller and your speed is getting smaller and smaller. But if you think about it, if your velocity is currently a negative number, like if you're going negative 50 miles an hour and it starts quote unquote decreasing, then it's going to like negative 60, negative 70, negative 80. Your actual speed is increasing. So let's find out what V of 2 is. So VQ of 2. If I plug that in, 2 squared minus 8 times 2 plus 15. I wind up getting 4 minus 16 plus 15. 19 minus 16, I got 3. So since velocity is currently positive and it's decreasing, since velocity of q at t equals 2 is positive and decreasing, the speed of q, which is the absolute value of velocity, is decreasing as well. So all right, part D, find the position of particle Q the first time it changes direction. The first time it changed the direction. So if we go back to our, so let's see, looks like we start out going right, then we change to left at t equals 3. So I need to find the position of Q at t equals 3. So the way we're going to need to do that is we're going to need to take the integral of t squared minus 8t plus 15 dt. So when I integrate that, we will get our position, which we can say SQ of t. So we get t cubed over 3 minus 4t squared plus 15t plus c, right? And we know our initial condition for this. We haven't used this at all yet. Particle Q is at x equals 5 at t equals 0. So if I plug in 0 for t, I get 5. Oh, that's super easy. 0, 0, 0, 0, 0. So c equals 5. If we plug in 0 for t, gone, 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 just get that. And now it just asks us for find the position the first time it changes direction. Well, remember, Q changes direction at t equals 3. So SQ of t is equal to t cubed over 3 minus 4t squared plus 15t plus 5. And now I just plug in 3. So that's going to be 27 over 3, which is 9, minus 4 times 9, which is 36, plus 45, plus 5. That's 50. It's 59. Now, I'm doing something I shouldn't be doing right now. I should stop here. But I can't help myself. So 59 minus 36 is 23. So the position is 23. All right. So This is a different way than they did it. This is the way that I chose to do it. I'm correct. So the way that they did it was they said they still used the same time t equals 3, but they said that the position at 3 is equal to the position at 0 plus whatever the integral from 0 to 3 is. They calculated that integral and then added in the 5. So it's kind of a pick your poison, whichever way you'd prefer. I think for me, I liked finding the actual function and then just plugging the number in. That felt simpler to me, but it's irrelevant. It doesn't really matter. Okay, we've only got one more of these to do, and we're done last year's AP test.